we now have the definitions of the trigonometric functions, and it's maybe time to do a little bit of thinking and discover one property of the trigonometric functions that relates to the unit circle, right? We defined the trigonometric functions on the unit circle, and namely we said that, cosine of t, that arc length along the circumference of the unit circle was x, and sine of t was y. So again, x and y came from our trigonometric point where that arc length ended, given that it started at the point 1, 0 on the unit circle. Okay. We also know that the unit circle has the equation x squared plus y squared is equal to 1. Well, if cosine is x and sine is y, can't we just say, instead of x squared plus y squared, we have cosine squared plus sine squared is equal to 1? Exactly, yeah. And this first identity or equivalency is one of the what we call Pythagorean identities. Okay, so cosine squared plus sine squared, and often when we write this, we typically write it as like cosine squared of t plus sine squared of t is equal to 1. I wrote it like this in the notes because some students have mistakenly put like the square on the t instead, and that's not okay. So just make sure that when we write cosine squared, it is take cosine of t, whatever that gives you, square it, and go forward from there. Okay, so when we talk about identity in the context of math courses, it's typically a statement of equivalency. Okay, so we can rearrange this. It is an equation, work from one side or the other, manipulate it how you wish. Also, we can get a few other Pythagorean identities as well. Okay, so we have one involving tangent and secant, and the other one involves cotangent and cosecant. Okay, so I kind of proved the first one, so I'm not going to prove it anymore, right? We just do a substitution, we're done. Okay, to get this second one, we have to divide by cosine to the first equation. So I take cosine squared of t, I'm using this notation, plus sine squared of t is equal to 1. And then since it's an equation, I have two sides, right? I can do something on one side, do the exact same thing to the other. So I'm going to divide by cosine to each term over cosine squared t. Okay, and when I do this, cosine squared over cosine squared is 1. Sine over cosine is tangent, and then both of those are squared, so it's tangent squared of t. And then 1 over cosine was secant, and that's squared of t. So that's my second equation, or second identity. And the third identity we get by taking our original cosine squared plus sine squared of t equals 1, divide everything instead of by cosine by sine. Sine squared of t plus, by sine squared of t is equal to 1 over sine squared of t. Again, what I do to one thing, I have to do to all things in an equation. So cosine over sine, that's the reciprocal of tangent, better known as cotangent, and we have to have that squared because both are squared. Sine over sine is 1, and then 1 over sine is cosecant, and that's squared of t. Okay, and that would be my third identity. Okay, I have cotangent squared plus 1, tomato, tomato. Okay, there we go. Very quick proof. Okay, how is this information useful? Okay, it's useful because we get to my favorite type of problems with it, at least for now. I have lots of favorites. Okay, so working with this first one, we have cosine, and then it says P is a trigonometric point in quadrant 3. Okay, I just need to get a quick little sketch so I know, okay, P is so it's on the unit circle, quadrant 3. Okay, and I know cosine is -2/5, right? I need to figure out what this is, what the y is. Okay, so let's see, it says find the value of the other trigonometric points at t. Okay, so I know x, right? So I can, if I know cosine, right, I can say automatically that secant of t would be the reciprocal, right? So -5/2. That's fine. But I don't know anything about sine and cosecant. I don't know anything about tangent or cotangent because I don't know what the y-coordinate is. But I know it's in quadrant 3. I know it's a negative number. Okay. So how do I find that y-coordinate? Remember, y is sine, right? So let's use, so I know I have x squared plus y squared is equal to 1. Yes, that is true. But again, on the unit circle, we have cosine squared of t plus sine squared of t is equal to 1. Okay, and I know what x is, right? X is cosine, and cosine is -2/5. Let me write that bigger. -2/5 squared. And then sine squared of t is equal to 1. Okay, go through the arithmetic. 4/25. Oops. 4/25 plus sine squared of t is equal to 1. Move that over. Sine squared of t is equal to 21/25. Okay, and then I introduce a square root. Sine of t is equal to square root of 21/25. Square root of 21/5. If you go through and do the arithmetic to simplify this. Now, again, when you introduce a square root, you have the plus and minus. Okay? This instance, I can't have both positive and negative. The positive or negative is dictated by the quadrant. In quadrant 3, I have a negative y. Okay, so I have to go with that. So I know sine is negative square root of 21/5. Cosecant would be -5 over square root of 21, better known as -5 square root of 21/21 if I rationalize. And then tangent would be y over x. So this is negative square root 21/5 divided by, I'm going to need more room, divided by -2/5. And when I simplify this, I get square root of 21/2. Okay, positive, negative divided by negative. Okay, and then similarly, cotangent would be the reciprocal. So cotangent of t would be 2 over square root 21, better known as 2 square root 21/21. Okay, if I rationalize. Okay. So again, I can, if I'm given one trig function, I can at least find a second by reciprocals, but then to go forward, I needed to use the Pythagorean identity to relate cosine to sine and then find something that I was missing. Okay. Next one, we were given tangent. I want to find the other ones. Well, okay, if I have tangent, right, I can get cotangent. Cotangent of t is just the reciprocal, -1/2. Okay, but I still need sine, sine and cosecant, and I need cosine and secant. Okay. Okay, so now I need to make use of something, right? So I also know it's in quadrant 4, so that's going to be a positive x and a negative y. Okay, that's helpful. But to use tangent, right, there is a Pythagorean identity that was 1 plus tangent squared of t is equal to secant squared of t. Okay, and so we're going to use this. Okay, I want you to pause the video, try it out, and see what you get for secant. And then once you get it, see if you can find cosine And then once you get cosine, find sine. All right, so here was my work to get the value of secant. Okay, substituted -2 and went through the algebra. Secant ended up being positive square root of 5 because I was in quadrant 4, and secant relates to the x coordinate. So I went with positive square root of 5. And then I found cosine. I still need to find sine, okay? A few different ways you could do this, okay? You could recognize that tangent of t is just sine of t over cosine of t. So then if you substitute in, you get -2 is equal to sine of t over, cosine was square root of 5 over 5, okay? And then multiplying both sides by square root of 5 over 5, you get -2 square root 5 all over 5 is equal to tangent of t. And then if you, so that's one way. You could also use, cosine square root of t plus sine square root of t is equal to 1 and find it that way. But, oops, that's not tangent, that should be sine. Oops. Sine of t. So that is -2 square root of 5 over 5. And it is negative, makes sense because it's in quadrant 4 and it's y coordinate. Okay, take the reciprocal 5 over 2 square root 5. And if you simplify this, oops, negative, you get negative square root 5 over 2 for cosecant. Okay, so there we go. Again, big punchline here are the Pythagorean identities. Make use of those whenever you're given one trig function and you need to find more.